Welcome to Part 2 review for the state test. In this packet, we will review Part 2 style questions to prepare for the state test. Let's start with problem number 41. A teacher surveys a random group of students about their preference for doing classwork online or on paper. The results are shown in the table below. Part of the group, 17, like online work, and then the other part of the group, 8 students, like paper. Based on the results, how many students out of 350 would most likely have a preference to do their work online? We're asked to show our work in the space. Well, you're making a prediction about those 350 students based on a small sample of these students. Well, we need to see first of all, how many students total there are. As we add up 17 plus 8, we see that there's 25 students total. The probability that they would like online work is 17 part out of a total of 25. The probability that the next person asked would like to work on paper would be at a rate of 8/25 part over total. Well, in order to calculate or make a prediction about 350 students, we will use those rates. Actually, we'll use the top rate to help us predict how many people would like to work online. So for predictions, we use a tape diagram. We know we have 350 students. Please put this on your paper, which is 100% of the group. Part of those students like online work, and the other part will like to work on paper. But we're focusing on the online, and they have a rate of 17/25. So 17 out of every 25 students will have this preference. Now grab your calculator and turn that into a decimal rate. 17 divided by 25. 0.68, or 68% of the students out of 350 should like online work. So the last step, take your formula that goes with a tape diagram, R times T equals P, and do 0.68, that's the rate at which they like to work online, and multiply by 350. You should have gotten a prediction of 238 students would like to work online out of 350. Let's move to page 2. On page 2, question 42, hopefully the thing you notice most is that we have a 2-column T-table, which should make you think about X and Y, bivariate data. But let's read the question and see what's going on here. A student programs a robot to travel at a constant speed across the classroom floor. The table below represents the relationship between distance in feet the robot travels over a period of time in seconds. Write an equation that represents the distance d in feet the robot travels in t seconds. Using the equation, how many seconds will it take for the robot to travel 11 feet? Now, seconds would be in this column. That would be unknown. And 11 feet would be here. And they want you to work backwards, but you need to use the equation. Well, here we go. We should think of this structure when you hear about an equation with two variables. Now, we need to get the K rate, so we're going to put y over x. And in this case, we're going to put 1 over 2, and we can calculate the constant again, 2 over 4. Let's remember, instead of using y, we're going to have to use the letter d, so I'll put that on top for distance. And instead of using an x, we're going to use a t. So as we divide, 1 divided by 2, we get the rate 0.5. If we do it again, just to double check, we get a rate of 0.5 again here. So your K rate is 0.5. Instead of using an x, though, we're required to use t for time. And instead of using a y, we have to use a d for distance in feet. Now it's time to use the equation to solve this question. We know 0.5 is our rate. But right here, t is unknown. We don't know t, but we know we need to travel 11 feet. That's our d distance. We're going to drop a dotted line and solve this equation. We're going to divide both sides by 0.5 and figure out the time in seconds. Pick up your calculator and divide 11 divided by 0.5. Make sure you enter the decimal point. You should have gotten 22 seconds. Now let's move ahead and go to page 6. So we're going to skip a couple pages. On page 6, we're going to solve this problem. It says, a family of 2 adults and 2 children went to the fair. The the costs of admission and the rides are listed below. $11 for 2 adults, $5 or $11 for each adult, and $5 for each child, and $1.25 per ride. The family spent a total of $52 on admission and rides. And here's the most important part. How many rides did the family pay for? That's going to be our variable R for rides. We are solving for R, which makes me think, of course, of an equation. The variable term plus the constant term equals the total. Well, we know they spent a total of $52, so there's your total. And we know each ride, R, is $1.25. But before we look at the price for the adult tickets and the tickets for the children, we need to do a little calculation. We had $11 for each adult, but there were 2 of them. So we double $11. We know the adult tickets cost $22 so far. And $5 per child, and we have 2 of them. That's a total of $10. So 22 for adults, 10 for the kids means our constant is $32. It required a bit of calculation. So this is what was spent on the tickets to get into the park or the admission. Take a moment now and solve the equation now that you kind of calculated the constant, which took a bit of work. Take $32 away from both sides. Get rid of the admission cost. We are left with $1.25 times R equals, and when we subtract, we get $20 left for the rides. Now take and divide both sides by 1.25. Pick up your calculator and punch in 20 divided by 1.25 and hit equals. You should have gotten 16 rides. Now, let's move on to one more. We're going to look at page 7 together and work out problem 38. Maggie owns a dog grooming business. The prices for 2 services are listed below. $31.50 for a dog wash and $17 for a nail trim. A customer receives an 18% discount for paying for both a dog wash and a nail trim. What is the total price the customer will pay for a dog wash and a nail trim with the discount? Well, first, let's take a moment and add up the 2 services. Let's add up the 2 services and see what they total. You can use your calculator. And so far, we're at $48.50. But when you see discount, you should think of a tape diagram. Draw a tape diagram, and at the bottom, put the total, $48.50, that's 100% of what's owed. But we know you get an 18% discount. Cut the tape diagram, and this is the savings or the discount right here. You get to save 18%. But what do you have to spend in this part of the bar? That's what they're looking for, the total cost the customer has to spend. Well, if we save at a rate of 18%, we take that away from 100, we get 82%, or scoop, scoop, 82 cents of every dollar. We're looking for how much we spend. So we're going to use the formula R times T equals P. Take 82 hundredths times 48.50. Let's see how much the customer has to spend. Punch that into your calculator. 0.82 times 48.50 and hit equals. You get $39.77, which happens to be choice B. This concludes this brief review of Part 2 questions.